In this unit, we'll see how we can use the imaginary number I to solve any quadratic equation. Let's have a look at an example. Suppose we want to solve the quadratic equation x squared minus 2x plus 10 equals 0. Now we're going to use the formula for solving a quadratic equation. This is the formula over here, and first of all we need to identify the values of a, b and c to substitute in the formula. Now the value of a is the coefficient of x squared, which in this case is 1. The value of b is the coefficient of x, which is minus 2. And the value of c is the constant term, which is 10. And we substitute these values into this formula. So here we go. X equals minus b, which is minus 2, which is plus 2, plus or minus the square root of b squared. B squared is minus 2 squared, which is plus 4, minus 4 times a, which was 1, and c, which was 10, all divided by 2a. And 2a is 2 ones are 2. Let's tidy this up. We've got 2 plus or minus. Now let's look under the square root sign. We've got 4 subtract 4 times 1 times 10. 4 times 1 times 10 is 40. 4 subtract 40 is minus 36. So you'll see we've got a square root of a negative number here, the square root of minus 36. And it's all divided by 2. Let me remind you how you deal with the square root of a negative number. The square root of minus 36 we can write as the square root of 36 times minus 1, which is 6 times I, or 6i. So the square root of this negative number, the square root of minus 36, simplifies to just 6i. And finally, if we just want to tidy this up a bit more, we can notice that there's a factor of 2 in the numerator and the denominator, which can be cancelled, which will leave 1 plus or minus 3i. So here we have two solutions of the quadratic equation. One of the solutions is the number 1 plus 3i, and another is the number 1 minus 3i. Let's have a look at another example. In this example, we're going to study the quadratic equation 2x squared plus x plus 1 is 0. Again, in order to use the formula, which is here, we need to identify the values of a, b and c. The value of a, which is the coefficient of x squared, is 2. The value of b is 1, and the value of c is also 1. And we substitute these values into the formula. So we'll get x equals minus b, which is minus 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a, which was 2, and c, which was 1, all divided by 2a, which is 2 2s are 4. Let's tidy up what we've got, minus 1 plus or minus. Now let's look at the square root. We've got 1 squared, which is 1, subtract 4 2s are 8. So it's 1 subtract 8, which is minus 7. You'll see again that we've ended up with the square root of a negative number. Now the square root of minus 7 we handle in the same way as before. We write it as the square root of 7 times minus 1. The square root of 7 we leave as the square root of 7, and the square root of minus 1 we now write as I. So this solution we have here now simplifies to minus 1 plus or minus the square root of minus 7 we write as the square root of 7 times I, and the whole thing's divided by 4. And we can leave our answer like that, but if we want to, we can write it as separate terms. We can write it as minus 1 divided by 4 plus or minus the square root of 7 divided by 4 multiplied by I. So either of those forms are equivalent. We've now seen how we can write down the solution of any quadratic equation. A number such as this one, which has got a part which is purely real, in this case minus a quarter, and a part which is imaginary, that's the part that's this number here, root 7 over 4 multiplied by this imaginary number I. A number such as this is called a complex number. And in the next unit, we'll define properly what we mean by a complex number.